we'll solve some problems based on the inertial frame of reference and non-inertial frame of reference. Okay, so what we'll do is we'll solve the same problem in the inertial frame of reference and the non-inertial frame of reference. Okay, and you will see that the answers will be equal. So now whether to use the inertial or non-inertial, it's up to you. Okay, and it will consume same time also. So let's see this one. A block of mass m is in contact with the cart C as shown in the figure. The coefficient of static friction between the block and the cart is mu. So this block and the cart, the coefficient of static friction between them is mu. The acceleration alpha of the cart that will prevent the block from falling satisfies. Okay, so what should be the acceleration of this cart so that the mass doesn't fall? Okay, the acceleration which prevents the block from falling satisfies which one of these? So let's check. So let's suppose there is a person who is standing over here. So tell me which frame is he in, the inertial or non-inertial? It is inertial. Very good, right? The person is steady. Okay, so person is steady or in constant velocity, moving with constant velocity. The frame of reference is inertial if he is moving with constant acceleration. No, any acceleration, right? If steady or constant velocity, inertial frame, and any acceleration means non-inertial frame. Okay, so this one is inertial frame. This one is inertial frame. So this person observes what's happening and he writes down, he draws the free body diagram, okay, of this mass m. What are the forces acting on this one? One is the normal reaction, right? One is the normal reaction. Okay, let's draw this surface of cart 2. So one is the normal reaction which is acting in this direction. Okay, and there is its weight acting downwards. Weight is equal to mg, and there is the frictional force between these two surfaces which is acting upwards. So Fs, if it is not falling down, means the normal reaction must be equal to what? Normal reaction must be equal to what did I say? If it is not falling down, means its weight is totally supported by what? The friction. Okay, it doesn't fall down, so friction is enough to prevent it sliding. Okay, it's sliding down from this plane, right? So friction must be greater than or equal to what? Mg. And you know what is the friction? So friction is equal to mu s multiplied by normal reaction. So it is mu s multiplied by normal reaction. This is greater than or equal to its weight. And then there is the normal reaction due to the cart. And what's happening to this block? It is moving along with the cart. So that means it is accelerating. And who is providing that acceleration? So which is the force in direction of acceleration? It's the normal reaction. What you can say is normal reaction provides normal reaction. Okay, so this person will say, oh, this block is accelerating in this direction and normal reaction is acting like this. So which is the force that results into the acceleration, which causes the acceleration of the block? It is the normal reaction, and therefore normal reaction is just equal to that mass multiplied by its acceleration. Acceleration is alpha, right? So you just put that over here. So you get mu s multiplied by m times alpha is greater than or equal to m times g. Okay, and then gets cancelled out, and you have alpha is greater than or equal to g divided by mu s, because m is cancelled out. Okay, so this is the answer. alpha is greater than or equal to g divided by mu s. So that is option C. Okay, this thing is clear, everyone? Yes, no? Right. So this is inertial frames of reference approach. Now we'll see the same problem in non-inertial frame. Non-inertial frame. Okay. So now suppose there is this part, it is made of the glass, and there is a person standing or sitting inside this cart. Okay, and he sees that there is this block. Okay, there is a block. Okay, and it's not moving at all. Okay, it's not falling down, right? And somehow he knows that there is no adhesive connected over here. I mean, it's not stuck with this wall by means of an adhesive. Okay, that's the assumption, right? Okay, so then what he will do is he will also draw free body diagram. Okay, but then he is in non-inertial frame of reference. So since he is in non-inertial frame of reference, so he feels an acceleration in this direction, right? So he feels a pseudo force in opposite direction. So that's why he will say the mass of this block is m. So there must be a force acting on this block in the opposite direction, right? So for this person, the block is steady, means he knows that there is normal reaction which is acting in this direction. But then if there was normal reaction, then the block wouldn't be steady. Okay, if there was only one force acting in this direction, the block wouldn't be steady, right? So for him, the block is steady, right? For himself, he is steady, the other world is moving in backwards direction with some acceleration alpha. He is steady, the block is also steady because block is over here only. Okay, it's not sliding down, it's not moving up, right? So he sees that block and for him it is steady. This thing is clear? Yes, no? The block is always moving along with him, right? So therefore he says that there is normal reaction. Definitely there is a normal reaction which is acting in this direction. So now since the block seems to be steady, there must be a force acting in opposite direction. Okay, and how much is that force? So that force is equal to the pseudo force. Sorry, it is pseudo force Fp. And what is pseudo force? Okay, so since the block seems to be steady for this person, okay, since block seems to be steady for non-inertial observer, since block appears steady for non-inertial observer, you can say that normal reaction is just equal to the pseudo force, okay, and that is just equal to what? Mass times alpha. So for him, the world is accelerating in this direction, okay, and they are steady, right? So what is the pseudo force? Pseudo force is just mass into acceleration. The normal reaction is mass multiplied by alpha. So we know that the pseudo force, it appears to be acting in the opposite direction of acceleration, and what's the magnitude of that? Just mass into acceleration, okay. And then it's very simple. So he says, okay, so now it seems to be balanced, so normal reaction is in this direction, and he found the magnitude of normal reaction, okay, it's m times alpha, by a completely different argument as that of compared to what? This observer. So he found that n is equal to m times alpha, and then you have Fs must be equal to what? Mg, because it's not falling down. Okay, if it is not stuck with the wall by some adhesive. Okay, so then you have Fs is equal to what? M multiplied by G. Okay, and that is mu s into normal reaction. So Fs must be greater than or equal to M multiplied by G. Okay, so Fs is mu s multiplied by normal reaction. It's greater than or equal to mg. If it is not falling down, then it's equal to mg only, right? Okay, so n is equal to what? M times alpha, that is greater than or equal to mg. Mm gets cancelled and you get mu s is g by, sorry, alpha is g by mu s. You wanted alpha, no? So alpha is greater than or equal to g divided by mu s. So that's the answer, right? So the same answer you can find out using completely different argument. So this thing is clear, how to use inertial and non-inertial. Everyone? Okay, let's see another problem. Let's see another problem. A block of mass m is placed on a smooth inclined wedge. So this is a wedge and a block of mass m is placed over that. ABC of inclination theta. So theta is the inclination. This is theta shown in the figure, as shown in the figure. The wedge is given an acceleration a towards the right. Okay. The relation between a and theta, so acceleration is a and theta, for the block to remain stationary on the wedge is. This is the question. Okay. The block remains stationary is given, and then what should be a? What is the acceleration? This is the question. So again, let's draw a free body diagram of this mass. So this mass is m. Mass is m. Now see, the system is accelerating in this direction. Whole system is accelerating in this direction. Okay, and acceleration is a. So now once again, let's consider an inertial observer who is here and he watches that system. Okay, inertial observer watches the system. So for him, the system is accelerating in this direction. The block is also accelerating in the same direction. What are the forces acting on the block? So there is one normal reaction acting like this. This is the normal reaction, and there is weight which is acting like this. Okay, mass is m, this is g, and this angle is theta. So then what will this observer do? So he knows that he must resolve the forces in the direction of motion and perpendicular to direction of motion, right? Okay, he needs to resolve the forces perpendicular to direction of motion and in the direction of motion. Why? To check for the equilibrium. Okay, so then resolve the normal reaction in along the two components. So what will be those two components? So if this angle is theta, this angle is also equal to theta. This angle will be 90 minus theta, right? This angle will be 90 minus theta. Then what would be this angle? So this angle is again theta. Okay, so once again, this angle is theta, so this is going to be equal to theta. This is equal to theta. What is this angle? This one is 90 minus theta. Oh, what did I say? This angle is theta, so this angle is also going to be equal to theta, right? This one and this one, right? Two parallel lines and the intercept. So this angle is theta, so this is also equal to theta. This is theta. This one is going to be equal to 90 minus theta because this total angle is 90 degrees. And if this is 90 minus theta, then this angle is going to be equal to theta. So this angle is theta. And now let's resolve n. So component through the angle is cos component, component away from angle is sine component, right? So resolve n along two components. So you get this component which is n sine theta, and you get this component which is what? N cos theta. Okay. And now once he resolves the forces, it's very clear to him that what must this vertical component do. So the vertical component of normal reaction, n cos theta, it just supports the weight. Okay, it balances the weight. So n cos theta is equal to mg. He writes down this. Then what does the horizontal component do? So n sine theta, there is only one force in the horizontal direction, and it must provide this acceleration. Okay, it must cause this acceleration because he sees that the system is accelerating, right? So for this block, which force causes the acceleration? It is this n sine theta, right? So n sine theta must be equal to m times a, right? And then we wanted to find out a, so this is equation 1, this is equation 2. So what we can do is we can just divide equation 2 by 1, right? Equation 2 divided by 1. What do we get on left hand side? It's n sine theta divided by n cos theta, and that's equal to m times a divided by m times g. Gets cancelled out, then nn gets cancelled out. So sine theta by cos theta is tan theta. Tan theta is equal to a divided by g, and therefore a is just equal to g tan theta. So this is the answer, option D. Okay, this thing is clear. Okay, so once again, which way was this one? This was the inertial way, right? So once again, let's solve this problems, the same problem using non-inertial frame. So the same one, yeah, same one. So let's solve this one using non-inertial frame. So there is some person who is also sitting over here, okay, on the wedge. The person is sitting on the wedge, and he sees that he is steady, he is not sliding down. The block is also steady, block is also not sliding down. Okay, he is steady and he sees that the wedge is accelerating in this direction. So there must be a force on him also in this direction. That's the pseudo force. Okay, if the wedge accelerates like this, imagine it's like when you are sitting in a bus and bus accelerates in forward direction. You feel a force in backwards direction just like that. You will also feel force in backwards direction. Okay, the magnitude of that is his mass multiplied by acceleration. Okay, acceleration is a, right? So m times a, and then he reasons that there must be a force on m also, this mass also, okay, which is in opposite direction of the acceleration. Okay, but for him, he is not accelerating, block is not accelerating. For him, there is one component of normal reaction which is acting in this direction. So there must be another force acting on the mass also, which is acting in opposite direction. That is the pseudo force, right? So for him, the world is accelerating in backwards direction. This thing is clear? Yes, no? Okay, so the only difference is there. See, this normal reaction he will also see, then mg he will also see, and he will also resolve the normal reaction in two components. But for him, the block is steady, block is not moving. So if normal reaction, this component of normal reaction is towards right, so there must be one force towards left. Okay, there must be a force towards left which balances that component of normal reaction. So what is that force? It's the pseudo force. Okay, so non-inertial frame of reference also, weight is balanced by the vertical component of normal reaction. So n cos theta is equal to mg, and n sine theta is equal to what? In magnitude it is equal to what? The pseudo force Fp. And what is the pseudo force? So we know the magnitude of pseudo force is equal to what? Mass multiplied by acceleration of the system, m times a. Okay, so then it comes out to be same, right? Next steps are same. There is only one difference, that is the difference in thinking. Okay, this thing is clear? Yes, no? Right? So then you can just divide this thing by this thing. Okay, equation 1, this is equation 2, right? 2 by 1 will give you the same thing. So tan theta is equal to a by g, and therefore a is equal to g tan theta. So what's the difference between inertial frame and non-inertial frame of reference? The only difference is the observer observes from outside. Okay, observer is steady, right? Or he is in uniform motion, so there is no acceleration. Then he sees that the system is accelerating, or this mass is accelerating. So it must result from what? It must result from some real force. And what's that real force? In this case, it is the horizontal component of normal reaction. And in case of non-inertial frame of reference, so he sees that there is horizontal component of normal reaction acting on this block, but for him, he is steady, the wedge is steady, the block is steady, everything is steady, right? The remaining world is moving in backwards direction for him. Okay, so there is the force which is keeping it steady in reference to him, and that's why he says that there is a force acting in opposite direction, okay, to that of his own acceleration. He doesn't know that he is accelerating, right? This thing is clear? Yes, no? So that force balances the horizontal component of normal reaction. Okay, so the difference between inertial and non-inertial. Good. So now, will you be able to solve problems based upon inertial and non-inertial frame of reference? So actually you need to stick to one. It's not like you need to master inertial frame also, non-inertial frame also. Okay, so if you can think in terms of inertial, stick to inertial. Okay, and I don't even find a difference. I mean, see, in this case and also in this case, I required same time. Okay, here we did it little bit quick because we already knew the next steps, right? So personally, I don't see a difference between inertial and non-inertial. The time taken to solve the problem is also same. Okay, right? And these kind of problems are repeated also. So if you do them repeatedly again and again, so you will know that A is equal to g tan theta, right? So if they ask what is A is just equal to g tan theta, then there is no need to spend time in the exam. Okay, in practicing, yes, you need to spend time, but not in the exam, right? Let's see next one. A block of mass m is placed on a smooth wedge of inclination theta. The whole system is accelerated horizontally so that the block does not slip on the wedge. The force exerted by wedge on the block will be, okay, tell me, force exerted by wedge, that means they are asking about the normal reaction. So it's the same thing. They have not given the diagram in this one. In this case, the diagram would be same, and then this is the wedge, okay, this is the block, there would be this normal reaction acting on the block, right? Then it's very simple, right? So we know that what we had just found, no? So A is equal to g tan theta, okay. Force exerted by wedge on the block will be, force exerted by wedge on the block will be, okay. So here you can just say that n cos theta is equal to mg, right? N cos theta is equal to mg, and therefore what will be n? It is just mg divided by cos theta. That's it. You want force exerted by wedge on the block, so that is the normal reaction. What is normal reaction? It is just this weight divided by cos theta. This thing is clear. Everyone? Indusha, is it clear?
Yes, sir.
Okay, good. So that's why the answer is option D. Okay, it's the same as that of last problem, but they asked for the different thing here. They asked for the normal reaction. Okay, let's see next one. Now you will tell me this. A mass m is placed on very smooth wedge resting on surface without friction. Once the mass is released, the acceleration to be given to the wedge so that m remains at rest when m remains at rest is a. Where? So what is a? This is the question. A is applied to left, and a is equal to g tan theta. A is applied to right and a is equal to g tan theta. A is applied to left and a is equal to g sin theta. A is applied to left and a is equal to g cos theta. Which one is correct? Tell me. Everyone? Yeah, it is option A, right? So in this case, you can see the inclination of plane was like this. Okay, so when you give some acceleration towards right, then it provides for the normal reaction. Okay, so imagine if you provide the acceleration in opposite direction, what will happen? It was already slipping. Okay, the mass was going to slip and you are taking the wedge away. It's like that, so it will slip faster. This thing is clear, right? So the acceleration cannot be towards right. So if you are giving acceleration towards right, that means it was already moving down and you are moving the wedge away, okay, away from it, right? So it will slide down even faster. Okay, can you imagine that? Yes, no? Right. So answer is what? It has to be towards left to provide for the necessary normal reaction. Okay. If you are giving acceleration towards right, means you are decreasing the normal reaction. Okay. If you are giving acceleration towards left, that means you are supporting it. You are giving some normal reaction. If you are giving acceleration in opposite direction, that means you are removing the normal reaction, decreasing the normal reaction. Okay. All right. So A is applied to left and G is equal to A is equal to g tan theta. That's the answer, right?